Hello, welcome to Ludic Science. In this video, I will show you how I built this spark gap switch that I will use for the experiments with the capacitor bank. Most of the experiments with a high voltage capacitor bank, for example, dumping all the energy into a coil to create a very high magnetic field, require discharging all the energy of the bank in a fraction of a second. That is a very high power level on the order of several thousands of watts. Therefore, we cannot use a common switch to turn on and off the bank because the contacts of the switch will burn immediately. Next time you need a PCB for your electronics project, consider using the professional services of JLC PCB. JLC PCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. One option is to use high-power thyristors, such as these ones, but the disadvantage is that they are very expensive. So we will use a spark gap, triggered spark gap. The spark gap works in a very simple way. Suppose that this is our capacitor bank and we want to discharge the bank into a coil. The spark gap is nothing more than two pieces of conductor, two pieces of metal, very close to each other. The current cannot travel the circuit because there is an air space between the terminals of the spark gap. But remember that if the voltage is high enough, a spark can jump from one terminal to the other, closing the circuit. So this distance must be larger than the distance at which the voltage will cause a spark. So how can we make the spark to jump from one terminal to the other? One option is to bring one of the contacts close to the other until the spark jumps and the capacitor discharges into the coil. But this presents mechanical problems. We need to find a way to move one terminal to the other. And there is another more easy way to do it. And that is by making the air between the terminals conductor. And we can make this by ionizing the air in this region. In order to ionize the air surrounding the spark gap, I will use this small high voltage power supply that has an output of several kilovolts, which is more than enough. This is the full circuit. We have our capacitor bank, our load, and this is the spark gap. Here we have the high voltage power supply. One terminal goes to one of the terminals of the spark gap and the other is placed close to the space between the spark gap's terminals. And we have a battery to power the small high voltage power supply and a push button. When we press the switch, an arc is formed here, ionizing the air, and then the current from the capacitor can flow through the spark gap and into the load. And here is my spark gap. Used two pieces of thick copper wire. This is gauge 10, and here we have the terminal that is connected to the high voltage power supply from here to here. Therefore, the spark forms in this region between the two terminals, ionizing the air. And as you can see, there is a small gap around 1 millimeters between the terminals of the spark gap. Well, this is my full setup. Here we have the spark gap, the high voltage power supply, battery to power the high voltage power supply, and a push button switch. When we press the switch, you can see the spark in the middle of the terminals of the spark gap to ionize the air. And I've been using this small capacitor bank. It is connected to the spark gap and then into a very fine copper wire. So my intention is to vaporize the wire when the capacitor discharges into the wire. However, maybe the small bank will be not enough, but this is just a test of the system. And I am using my capacitor charger. I made a video previously. If you want to check it, the link is in the description. So we charge the capacitor bank and then we discharge into the small wire with the button. So let's see. Okay, so let's charge the capacitor bank. 500 volts, and let's see. Okay, you can see how the voltage went from the 500 to 70 volts because when the spark gap activated, all the energy in the capacitor discharged into the small wire. However, it did not break because there is very small energy in the capacitor bank. Let's put some more voltage in the capacitor bank. (870, 150 volts). Okay, there you have it. The voltage went from 700 volts to around 100 volts. There is a small residual charge in the capacitor bank. Okay, so the spark gap works pretty well. Therefore, I will use it in my experiments with the large capacitor bank, this one that I built in a previous video. If you want to see the construction, the link is in the description of this video. So I will make several experiments using this large capacitor bank in forthcoming videos. For today, that's all. Thanks for your visit and see you in the next video.